Hi guys, Cheshire here. Welcome to this new module which is about understanding subsystems. So far we have understood computers, we have understood what servers are, we have looked into operating systems, and we also talked about subsystem. It's now time that we dive into some commonly known subsystems which are installed on Windows Server. And once again, if you are going through this course with an intention of getting your first job as an IT intern engineer, then knowing about these subsystems is good enough for you. But if you are going through the course to become like a senior IT engineer or somebody, then it is very important that you understand these subsystems in detail and you do more and more practice on them so that you have a very good knowledge about them. So here's what we are going to cover. The number one is web server. That's how you host websites. And we are specifically going to talk about IIS because IIS is Microsoft's web server. And this training is mostly about Microsoft. Then we are going to talk about ports. These are network ports. We could have covered the topic during our network training, but it makes more sense when I put it here and you will understand it. Then we are going to talk about the file servers. We are going to talk about the FTP servers, and we are going to talk about the terminal servers, and then we'll briefly touch upon the Citrix servers. Again, the point of view is that you understand the meaning of these things and they don't sound alien to you when they are discussed in the common general conversations during your career and during your work. You need to have an understanding of all these things because I find so many people nowadays who don't have a basic understanding of what an FTP server is or what are network ports and stuff like that. And these kind of things actually haunts them and they make unnecessary things very difficult for them to understand. So let's go ahead with this. Okay, so the number one topic is web server or IIS. Like I said, that's Windows Web Server. Every website that you see today is a collection of web pages designed in HTML, PHP, various scripts, and ActiveX controls and Java controls. But ever wondered how so much of information is provided to you in a controlled and systematic fashion? Well, that's what a web server do. Let's begin with a Google definition. A web server is a server software or hardware dedicated to running this software that can satisfy client requests on World Wide Web, www. A web server can, in general, contain one or more websites. A web server processes incoming network requests over HTTP protocol and several other related protocols. All right. These are various kind of web servers. So you have an Apache web server, that's a Linux based web server. You have got Microsoft IIS, which is Microsoft web server. You have Apache Tomcat, you have Oracle iPlanet, you have got Cherokee, you have got Lightspeed, you have got Tornado. And honestly speaking, this is a very small subset of all the web servers which are available. Now, all of them do the same job. Some have some additional features, but fundamental technology they work on is the same. If you learn one, then you will be able to navigate most of them easily because the fundamental principles behind the web server and the website navigation is exactly the same. IIS is the Microsoft Web Server which comes bundled with the Windows Server. It has come bundled with Windows Server since Windows 2003, probably even in Windows 2000, but I don't remember that. But since then, it is part of the Windows Server and you don't need any additional license to install Microsoft IIS. It's not just needed for hosting external website, but it is also used for a lot of applications. When you install them, applications or subsystems, when you install them on Windows Server, it is a prerequisite requirement of these application and subsystems to have IIS. Subsystems like Exchange or the PKI, Public Key Infrastructure, because they host some websites which the internal user of the organization they use to use the functionalities of this subsystem. So it's not that you need IIS just to host the website which you see over like internet, and you go to different Yahoo or Google or whatever sort of websites. It's also for the internal websites. A lot of you might be aware of the Outlook Web Access. This is the web access panel which you use to log into your organization Outlook email. Now, Microsoft Exchange hosts this Outlook Web Access on IIS. So as an IIS is a prerequisite for installing Microsoft Exchange on a server. So you have to install IIS first, and then only you can install Microsoft Exchange, because Microsoft Exchange need IIS to publish its websites. Along with that, a lot of other softwares also need IIS, and hence IIS become integral part of troubleshooting. Again, not when you want to host a website which is accessible to the world, but just because you want to install certain softwares which your organization needs, IIS is part of that. And like I said, there are so many listed softwares. I don't know which of these web servers are paid or which of them are free. And like I said, there are numerous more of these, and you can learn pretty much all of them, and if you want to, but there is no point. The basic requirement is that you have to understand the fundamental of how a web server works, and you will be able to use those fundamentals in any one of these web servers if you ever need to look into them. Honestly, I have not needed to look into anything apart from Microsoft IIS and Apache Tomcat, and maybe a couple of more web servers which are not listed here in my career of 15 years. So it's not something which you will be looking at every other day. But Microsoft IIS, being a Microsoft engineer, you need to know it. So like I said, that our focus is on IIS. IIS is a pack of standard Windows Server installation and can be installed on any server as a server role. Let me show you how do we install IIS. So I have listed down the steps here, but it will be a lot easier if I actually show it to you on your Windows Server. So let's go there, and once again, this is my virtual machines in Azure, and this is the IP address. Remember, whenever you deallocate the machine, I told you about stopping it. Whenever you deallocate the machine, next time when you start the machine, this public IP will change. So you will have to update your RDP file with the new public IP address before you try to remote into this server again. One more thing which I want to tell you is that we have an option here of auto shutdown. So it'll be really good if you set up an auto scheduled shutdown on your virtual machines in Azure, so that these machines can go off by themselves and stop eating away your money even if you forget to turn them off. Alright, so let's go to my IIS server. I'll go here, I'll double click on this, and see, this is the correct IP because I forgot to turn off my machine last night, so the IP hasn't changed. Alright, so we are on our Windows server. This is the server on which we installed Hyper-V yesterday. Now we are in the server manager. I will once again and go and show you where to open server manager from. So I click here, and yep, this is the server manager. And you click on manage, and you go to add roles and features. You can do it on your own virtual machines. If you have installed virtual machines and Hyper-V on your own computer, you can do it there. Or if you are using Azure for learning, then you can do it here like I'm doing. So again, role and feature-based installation, and click next, and the local server, which is your server name. And then you go here and you look for IIS, and you say add features, and you say next, say next, next, okay, next, and you say install. So it's installing IIS. Alright, so the IIS installation is finished. It did not ask you to reboot the server. There are some roles which when you install it will not ask you to reboot the server, and that's totally normal. And you go ahead and go to Windows Administrative Tools, and you look for IIS. See, it says new here. Whenever you install something new and you open it for the first time, until then it says new here. And well, this is the standard console of IIS. And by default, it creates a website for you. This is your default website. And we are going to create an HTML file to as a home page for our website. So this is how I create an HTML file. Hello, welcome to my website. You have to remember that HTML is the most loose encoding format which you are going to find ever, and you can write whatever, and that works actually. So you go ahead and you do a save as, and you go to the C drive of your computer, and you go here and you create a folder, let's say called as website, and you go here and you name the file default.htm. I'll show you that you have a couple of options to name it, or you'll have to change the configuration of the default website. I'll just show it to you, but it's best that you name the file default.htm. Okay, so now the website homepage is ready. Let me show you how the website homepage will look like. So you go here and you double click on this. Okay, so this is how the homepage of the website is going to look like. So now let's go ahead and host this site on our web server. So we do add website, and we can name it anything. So we can say test website, and the physical path of the site is it's in the C drive. Okay, and you can say test settings. Okay, it says cannot verify the access to it, so I wouldn't go into the troubleshooting of that, but hopefully this should work. But ideally these both should come green. You should be able to, or the IIS should be able to access that page. Now let's talk about the binding. So binding is the way in which your website is defined. You have multiple IP addresses on the machine, and you can have only one website running with one combination, and that combination is a network socket. We are going to talk about it in the next section, but before we discuss that, so you have one option. Either you can say that your website is going to run on all IP addresses, basically all the IP addresses that this machine has. Currently this machine has two IP addresses, one IPv4 and one IPv6, and it can be accessed on both the IP addresses, and it will work on port 80. That's the default configuration. And this is the test website, and we have run it. Let's try to browse it. Let's see what happens. Okay, see, welcome to my website. So we are able to browse this website. It is running on this name right now. What we need to understand is that any request which comes to this server for port 80 will hit on this website, because this website is running on port 80. I'll also show you CMD, netstat. This is a tool to check what's running on port 80. So you can see that there is stuff which is running on port 80. And this is IIS. I can even show you if it is which process is running on port 80. Okay, it's not able to, but it is IIS, but it's not able to tell you because it's running in system context. This process ID 4 means system. So it's not showing that information for some reason, but it is IIS which is running here. So this is your test website, which you hosted on IIS. Now, there is a lot of settings which are available in IIS, and you can go ahead and do all these settings and do a lot of things here. You can put your SSL certificate here. You can say require SSL. That means this website will only open on SSL, or you can go ahead and add an SSL certificate here. You can say HTTPS, and then it will let you select an SSL certificate for your website. So all these things are possible. Again, I don't want to go into the details of troubleshooting IIS as part of this training as of now. But what you need to understand is that IIS is a web server, and as soon as you install IIS on the component of IIS, which we did from Server Manager, this server becomes an IIS server, and that's it. That's what a web server means. All right. Now, let's see, what do we have in our training? So I just showed you how to install IIS. I also showed you the console of IIS and the basic terminology of IIS. So let's look into this. IIS host, it's a machine that is hosting IIS on your computer. So the server on which I installed IIS is IIS host. Web application is the website. Usually they are referred as web application. Then they are very data driven and not a static site. So any website which is running on IIS is a web application. So that's what I showed to you. These are our web applications, and you can do add site here. Application directory, essentially a child website. It can have its own application pool, but the settings are also inherited from a parent website. Once again, if you're learning this course from the point of view of getting your first job, then knowing about IIS is more than enough for you as a web server. And all these details is like you can add these application underneath it or add a virtual directory underneath a website. So all these options are available, but they involve deep learning of IIS, which is not the target of this course. Virtual directory, a directory of a website that has a physical location that is different than the website itself. One common name. These are all IIS terminologies. You may want to get into them if you are specifically trying to work on IIS for a project. Application pool. So basically to group the resources which are going to be used for a website, you create application pools. And this is where the application pools are. Bindings, I showed you the bindings here. So when you go to the website, here are your bindings. The bindings basically says that on what port and what IP the website is available. So this website is available on any IP, that is all the IPs which are running on this computer on port 80. You can add another binding and you can say that this website will be available on IP addresses running on this computer on port 4525. Okay, now let me show you that you go to localhost and you do port 2525. Voila, you still got the same website. So these bindings and options are available here if you want to put your website. If there are so many websites here, just imagine a situation when there are multiple websites, because each web server, when it is used in a production environment and especially in a commercial environment, like when you are hosting your websites with GoDaddy and other people, they don't give an individual web server to everybody. What they do is that they go ahead and create a website in an existing web server. So your data is just kept in the C drive of that computer. Like you have this website here. Yep. So your website is put in a folder in their C drive or whatever data directory that they want to. And then a website is created in their main IIS. And then we need to understand that all the websites, that server they cannot give like 100 IP addresses to a server. Server will most likely going to have one IP address. So the bindings is what uniquely differentiate these websites. So what are the parameters of binding? The number one binding parameter is the host name. Host name is the name of the website. So if you have multiple websites on a web server, one of them would be www.google.com and another one could be www.yahoo.com, because everybody would want their website to be accessed on the default protocol, that is port 80. And once again, we are going to read about the protocols and ports in the section after this, and then you will understand a bit more about it. But and everybody would want, and you cannot have more than one IP address on the machine. So pretty much this column is going to remain same for all of them. This column is going to be port 80 for all of them. So the only way you can uniquely differentiate between the websites, or let's assume when a request reaches this web server, how does it know if all the requests are coming on the same IP address for the same port? Then how does it know that to which website it has to redirect that request? So that's where the host name come in handy. It is the host name of the website which tells the IIS which website it has to provide, because you can imagine that there are hundreds of websites here and all the requests are coming for the same IP for the same port, and the IIS has no ways of identifying which website it needs to respond with, and that's where the host name comes into the picture. So this is what basically I wanted to tell you about IIS. As a practice, I would like you to go ahead and install IIS and maybe do a bit of a website creation and all these things so that you get a hang of IIS and you understand what is a web server. Okay, so I already showed you how to create a website. Just go ahead and create a website and see if it works. Network ports, yeah. So I was missing this topic, and I think this topic should have been taught before the IIS servers. So I'm just going to teach you this topic quickly, and then probably I'll just go back to IIS to just give you a review of what I said before as well. So what is a network port? Well, this topic could have been covered during the networks module, but I chose to keep it here so that it makes more sense. And to explain this, I will go back to my building and office in building analogy of public IP and private IP. So if you don't remember all that, or you skip that part of the training, please go back and refer to that module. Now considering that a computer is equivalent of a room inside a hotel or inside an office, and the room has 10 people, like a room has 10 people, computer has multiple programs running inside it or the applications running inside it. When you are trying to send data packet to a computer, it's actually destined for a specific application. It's not destined for a computer. Like computer in itself is nothing. It's all about the data which goes inside the computer and the data which comes out of the computer. So when you are sending a data packet to a computer, it is destined for an application. Just like the hotel package was destined for one particular person. When you send a packet to a hotel, it is not destined for a room. It is not destined for the reception of the hotel. It is ultimately destined for a person inside the hotel. Now, with that information, the address is a combination of public and private IP. Looks a bit incomplete. So far in our analogy, what we discussed was that an address is a combination of private IP and the public IP. So the public IP tells you the street address of the hotel, and the private IP tells you the room number of the hotel where you have to deliver something. But we are missing the information of who inside that room is going to receive that. What is the name of that person? So we need a port number as well to identify the application inside the computer to which the package is supposed to be delivered. Similar, in the example of hotel, you also need the name of the person who is inside the room to deliver a packet. So to deliver a packet to a computer, you need the application name, and the application name corresponds to the port number on which the application is running. Let's go ahead and look at the Google definition of a network port. In computer networking, a port is a communication endpoint. At the software level within an operating system, a port is a logical construct that defines specific processes or a type of network service. Well, I couldn't have found a better or a simpler definition, exactly suggesting what I said before. So the address combination is equal to the physical address of the computer, looks like below. So in a hotel, we had the hotel address, we had the room number, and we had the person name. So in computers, what we have is a public IP of your network, the private IP of your network, that is the IP address of the computer, and then the port number. That is the application which is running inside the computer which needs that data packet. Every application that run on a server has a default well-known port number. It is defined by Internet Assigned numbers authority. So INA is an authority which defines and identifies the port number. Just to give you a brief history, there are 65,536 ports, network ports, which are available in a computer. So in a way, if I was saying that a computer is equivalent to a room in a hotel, then there are 65,536 people who can live in that room. It's not necessary that all those people are living inside your computer at a given point of time, but it is very well possible that you can have 65,536 people living in that room, provided that your computer has the resources to manage all those applications. But as far as INA is concerned, you can have those many port numbers. So once again, there are a total of 65,535 ports behind an IP address, or as you can say, there are those many people inside each office. Below is the list of some well-known predefined ports, but most of the ports are open and unused and are available to be used. So you need to understand that just because I said that there are all these ports, it's not that they are in use. It is possible to have them, but it is not necessary to have them. So there are some well-known ports. Port 23 is reserved for Telnet. Port 22 is for SSH. Again, you may not understand what is SSH. It is a method of remotely managing a shell. Port 80 is for website. This is what we were looking at, IIS. Port 443 is again HTTPS, which is a website. Port 25 is SMTP, which is the emails. And once again here, port 20 is FTP, port 22 is a SSH, port 23 is Telnet, port 25 is SMTP, port 53 is DNS server, port 80 is HTTP or website or web server, port 110 is POP, which is the email protocol, port 143 is IMAP, port 443 is HTTPS, port 3389 is remote desktop. So these are the well-known ports. And once again, as an interview question, you should remember the number of these ports and the meaning of these ports, because sometimes in interviews it's being asked. A combination of an IP address colon port number is called as a network socket. So ultimately, it is the network socket which defines the destination of a data. So I'll quickly go back to IIS and I'll show you what I was showing you here. So this is the port number for HTTP, the protocol and the port number. And I showed you before here as well. These are the various known ports which are in use right now here on this computer. Okay, so okay, so we are not able to browse the websites because we have put bindings on them. Let me go back here. I have to remove the bindings. See, 0.2525 has become available. Let's try to browse the website again. So the website is available again. Anyways, so once again explaining to you, the port 80 is the network port which is used by this website. And the IP address is any IP address. So we can also change it to this IP address, and I'll just remove this binding for now. So any packet which comes to this IP address, which is the IP address of this server. Let me show you. And has the person name 80 or the port number 80 on it, it will be delivered to this IIS server. And hence, on this IIS server, this binding exists, which is going to tell this IIS server, okay, anything which comes for port 80, it is supposed to respond with the information of this test website. So that's what is the logic of a port within a server. It is equivalent to the person inside a hotel room. Hope you understand that. Now that we have learned ports, I want to introduce you to two sister concepts, which is port forwarding and NATting. Let's begin with port forwarding. Going back to the analogy of the hotels and room, a fully addressed package to be delivered to someone in a hotel will look like this: a person name, a room number, and a hotel address. Like for me, it could be Shashir, room 101, Hayat, Ramona Street, Quakers Hill, NSWAU. But unfortunately, the information of private IP is missing from the request because it's private. So a person who has a lot of servers running behind a firewall in a data center will not tell its server's private IP to people outside. So the packet which is received at the firewall at hotel reception, which is equivalent to our firewall, usually will have below information: a port number. This is a well-known information. I told you, INA has already published it. It could be HTTP port 80 or SMTP port 25 or RDP port 3389. It's a well-known standard. And a public IP address. This is the external IP address of your network, which is again a well-known thing. So ideally, a package which is received by the firewall or the hotel reception only have the public IP and the port number. That is the person name stamped on it. So on a hotel reception, a package will be received with the hotel address and the name of the person to whom the packet is to be delivered. There is no room number. Now it is the duty of the firewall, or once again the hotel reception, to look into its register of records to identify which private IP or which room number has this person or has this port number running on it, and send the packet to that private IP, to that computer or to that room, so that the packet can be delivered to that port number or to that person. And this process of looking into the register and sending the packet to the private IP is called as port forwarding. But this register, which firewall is supposed to look into, is not maintained automatically, but rather has to be created or maintained. And this process of creation of register is called as port forwarding. So let's look at the Google definition. In a computer networking, port forwarding or port mapping is an application of network address translation that redirects a communication request from one address and port number combination to another while the packet traversing a network gateway, such as a router or a firewall. So basically it is done on a router or a firewall, and it is a register which maintains this data. And as you can see here, this is kind of a table which is a port forwarding table, and I'll try to open my router and show it to you as well. Let me go to my router and show you. So I'll just go here, 192.168.1.1. I'll go here advanced, and yep, NAT and forwarding. Okay, so this is my public IP, and it is asking for the service name, which service. So you have to understand that service is equal to port number. Well-known services, well-known ports. So it is saying which service am I looking for. I'll say, let's say FTP, or I can say, does it give me an option to? Yep, so I can give a port number here directly. So what I'll do is that instead of choosing an application, I will say service name, and I will say RDP, and external port, that what port number will the request come with. So it will come with public IP colon port number. So it will come with public IP colon 3389. And what is the internal IP to which I have to send this request? I will tell it the IP of the machine to which it has to send it. I'm just putting a random IP here. And then it's asking me to send it on what internal port. Once again, I'm going to say 3389. And that's it. I go ahead and save this, and this is port forwarding, which I just did here. This happens on a firewall, this happens on every router, wherever you can do this. Okay, and I just want to quickly look at another concept which is just here. And that's called as NATting. And I actually showed you NATting just in that example, but I'll just explain it and then show you what I was referring to. It is a sister concept of port forwarding with a slight twist. Let's assume that you are a secret organization and you don't want to reveal the name of the person / port number of your application residing in your hotel / your data center. So you start lying to the outside world. When people send a packet for hotel address colon SAM, see, that's a network socket. Hotel address is equal to the public IP of the hotel, and SAM is equals to the port number or the person name. Your hotel will deliver it to hotel address colon Rob. So outside world will send a package for Sam, but the register which you maintain, it will deliver it to Rob. So you did a translation. So the world thinks that Sam lives in the hotel, but actually it is Rob who is living in the hotel. In terms of the network, world send a packet for port 80 and you deliver it to port 85. Let me go back to my firewall rule. So here, this was the rule. World send a packet for Sam, you delivered the packet to Sam. But what if world send a packet for Sam and you deliver it to Rob? So the whole world is sending the data as public IP colon 3389 and you are delivering it to an internal machine colon 85. This process of converting external port to a different internal port is called as NATting. Port forwarding is when the same port gets forwarded to the same port inside the machine. NATting is when the external port changes from internal port. Okay, so that's what NATting is. The Google definition of NATting: network address translation is a method of remapping an IP address space into another by modifying network address information in the IP header of the packet while it is in a transit across a traffic routing device. Traffic routing device means by router. Translation which happens in a router is called as NATting. So what we understood, we saw IIS, we saw the port mappings which happened on IIS, the bindings. We also told you what is port forwarding. Before that we told you what is a port, then we told you what is a port forwarding, and now we have told you what is NATting. Once again, these concepts, I know they are a bit difficult, but try to wrap your head around them. Try to Google and read more about them so that you understand these. And if you don't understand these, then talk to me and I'll be able to explain it further. Okay, now we are moving to the next subsystem, which is called as a file server. File server is the easiest and the most useful of all the subsystem we have spoken of because it is not a subsystem. There is nothing to install. Quite honestly, so far whatever or whenever I was installing or showing you something, I used to go on this server and I used to open the server manager and I go to manage, add rule and feature, and I used to go ahead and install something from this list. The fun fact is that to make a file server, although you can install these things and these add some kind of functionality, but you really don't have to, or by default, most of the file servers which you are going to look at in your life will not have any file or storage services. There is nothing to install. I call it a subsystem because it defines the server. A server which is being used as a file server will be used as a file server, and you will call it a file server, nothing else. File server usually is a server which has usually have a lot of built-in hard drive, or maybe drives attached via a network attached storage. So basically it is a high capacity server. The folders on these drives are created in a structure to resemble the business needs. So you create a lot of folders in your computer to resemble the business needs, and then these folders are shared with specific permission to end user, and they access them from their PC via a network drive. So I'm going to show you all this. Let's read the Google definition. The term server highlights the role of a machine in a traditional client-server scheme. That's the client and server thing which we spoke before of, where the clients are the workstation using the storage. So a file server is where the clients are the workstation using the storage from that file server. A file server does not normally perform any computational task. I told you this is not even, there is no software installed on it. It doesn't run any program or perform any computational task. It's not a server, it's just a storage. So let me quickly show you how do I make a file server. So let's say that this is a Windows server which I have to make a file server, and my business tells me that, okay, Shashir, you have a lot of drive here, and what you want to do is that you want to create folders for the sales team, you want to create folders for management, you want to create folders for accounts, and sorry about the spelling mistake. And you want to create folders for what is the marketing. Okay, you created these folders. Now what you do? You go ahead and share all these folders. Advanced sharing, share. I told you whenever you are giving permission, give permission everyone full control. And so far we don't have the users or the security created, but otherwise what we'll do, we will have probably a group. I'm going to show you the groups when we look into Active Directory, but I'll probably have a group called as sales peoples, and I will just go ahead, it's not able to find it because it's not there, and then I will give them full control on this folder. So they get the sharing permission and they get this. Now all these 4 folders can be shared, and okay, and what the users can do now, assume this is a user computer, because I don't have another PC right now, so that's why I'm showing it to you from here, but I will go ahead and create the client PCs for future so that I can show it to you from there. But let's assume now you are on a user's PC. So what the user is going to do, he is going to do start run, and he's going to put the IP address of this machine 10.0.0.5, and he's going to hit enter and say, okay, here's my share. And he will only see the share to which he has permission. He will not see all the shares. And he'll say, okay, I want to access data from here. And he says, map a network drive. And what is the drive letter? He'll say, okay, why? Finish. Now onwards, when the user comes to his computer, he has a network location available on his computer. And he can go here and he can create a file or a folder here. And the good thing is that this location is not on his local computer. It is on a file server. And this file server can be accessed by other people as well. So all the sales guy can put their data in this folder and it could be available to all of them. And from the backup point of view, you can just back up one file server and all the data can be backed up instead of doing it on a local individual PC. Now, this is what is the concept of a file server. That's it. Creating a lot of folders and sharing it with people and accessing them via the map drive. So don't be terrified next time when someone mentions a file server. It's just a computer like the laptop which you have right now. It has a server OS and it just have a folder structure to reflect the same things which you have on your computer. Okay? FTP server, very nice. I'm doing this specifically after IIS and file server because this is technically a combination of those two. Let's begin with the definition of it. The file transfer protocol is a standard network protocol used for transfer of computer files between a client and a server on a computer network. FTP is built on client-server model, so everything is built on client-server model. Now you need to understand that server is not like a voodoo thing, it's like just another computer which is providing some services. FTP is built on client-server model architecture using separate controls and data connection between the clients and the server. Okay, let's not dig too deep into that definition and read more about it. That's more of a protocol definition. But in simple words, imagine a folder on a file server and then you install IIS on that server and you create a website, and instead of a fancy design page shows this folder in a browser, and user can access this folder from a site and basically download and upload files. So look at this. This is a screenshot of an FTP folder. The FTP is a combination of a file server where you have created a folder and then you install IIS on top of it, and there is a whole procedure to create a FTP site. But the end goal is now this data, assuming for the people who are not inside your organization and they cannot access the data via the map drives, the drives which I showed you. Once again, I'll show you the map drive which we created. So if people are not inside your organization, they cannot access the data via a map drive. What they can do is that you can publish a FTP website for yourself, and this FTP website can be accessed from outside the internet, assuming for your clients or your business partners or people like that, and they can access this website and they can download and upload the data here. It's just a combination of IIS website and a file server. FTP has a specific port, it runs on port 22, and once again that port 22 is simply because the website which gets created in IIS, let me go back to IIS here, yeah, so the website which gets created in IIS will have a binding here for port 22. Remember, I showed you the well-known ports. The FTP is supposed to be on port 22. Sorry, port 20, not port 22. This is a question which you need to remember, guys. This is an interview question. So the FTP is supposed to be on port 20. That's the protocol. It's a well-known port. And quite honestly speaking, FTP is a bit of outdated concept. Most likely you're not going to see any more FTP servers. FTP servers are from the days when we did not have Dropbox and Google Drive and Sooners and all these SharePoint online kind of solutions available. These solutions, FTP was back in the olden days. Now you can easily share data with your partners and with your customers over Dropbox or over Google Drive or SharePoint or OneDrive and these kind of things. Basically, they are a very highly advanced version of the boring FTP server which used to look like this. So you should know about FTP server, but you should also know that you'll probably never going to encounter it anymore. Terminal server. This is the next one. In a Windows server environment, there exists a concept where multiple users can log into a single server simultaneously via RDP client on their PC and access application and data stored on this server. Until Windows 2003, this feature was called as, actually until Windows Server 2008, that is before Windows 2008, this feature was called as terminal services. And from Windows 2008 onwards, it has been renamed to remote desktop services because there are some additional features introduced to match Citrix compatibility. We'll talk about Citrix after this, but basically before 2003 or up till 2003, it was called as terminal services, but after 2008, they added some more functionality and Microsoft started calling it remote desktop services. Following are the use cases of terminal server. So when people use a terminal server, people trying to access office infrastructure from home, especially small businesses. So there are a lot of cases where we have seen that there are users who are at home and they have their home computer and they want to log into office infrastructure. So they log into the main server of the office, and multiple users can log in together, and they can access the files and applications which are installed on that server. Another use case is people trying to put a very controlled environment where end users can only use the system in a predefined format, like a call center, especially financial. So there are situations where people want a very controlled environment and they don't want to manage 20 different or 100 different computers. So what they do is they set up terminal server or a farm of multiple terminal server, and they put all kind of controls on it, and all the applications are available on this terminal server, and the users will log in from their computer into this terminal server to access the data. That's what terminal services is. I have also seen small companies where they are trying to save the cost of an individual PC and they buy thin clients. So thin clients are a computer which has very small hard drive. There is almost zero operating system. They only have a firmware on them. Remember, firmware is a most basic operating system which has just one job. So they have a firmware in which you can put the IP address of the remote desktop server or the terminal server, and as soon as you boot this terminal server, they will log in directly to the remote desktop server. So this is where people trying to save the individual cost and they just buy a small thin client. Use a single install application between multiple users, and also people have used it if they want to install an application which they don't have license to install on multiple PCs. Sometimes I have seen that people install it, although the application developers are becoming more and more smart now and they don't want their applications to get exploited by being published on terminal servers, so they kind of identify the use on terminal services, and some application maker restrict it as well. However, people, that doesn't stop people from using the application this way, and as long as the restriction doesn't come in, they use it this way. Now, default install of Windows Server also allows you up to two remote desktop servers into, like a two remote desktop users into the server. But when you install terminal services or remote desktop services, then the number of users can log into the server are of course limited by the hardware capacity of the server and the number of remote desktop CALs available. So we are going to talk about CALs, but I just want to explain RDP to you once more. So this session which I have made on this Azure server, this is a remote desktop session. Microsoft Remote Desktop Client is what I'm using, and I am remotely working into this server. So this is kind of what terminal services is. However, right now, you can see that there is only one user on it. Ideally, on a Windows server, you can have two users working on it remotely, and one user can work on it from the console session, like when he's sitting right in front of the machine. But that doesn't solve the purpose of terminal services, because you want to have 50 users logged onto it, and a Windows server is not going to allow that. So to convert or to install the terminal services, what you do is you go once again to Server Manager and you go to Manage Roles and Services, and you say next here, and there is an option to directly choose Remote Desktop Services installation from here, or you can say select individually, and then you can go here and you can select the Remote Desktop Services and you can do next, 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 and you can set it up as a terminal server. So, and how many users can log into it? Quite honestly speaking, if your computer has a lot of hardware capacity, if it has a lot of RAM, if it has a lot of processing power, a lot of number of users, there is no limit on the number of users which can log into a single server. So a lot many of them can log in. However, Microsoft is also very smart and it doesn't want you to exploit the Windows Server license. So what it does is they ask you to buy a CAL, that is a client access license, in order to access the number of users. So if you want to 10 users to access your remote desktop server, that means technically you are saving the cost of 10 Windows client. So they take away that client cost in form of RDP CALs. RDP CALs or client access license is Microsoft's way of kind of making up for that loss of sale of Windows client license. For every user you expect to log into your Windows server, you need to provide a remote desktop CAL. There are two modes in which CAL can be consumed. It is a per user or a per device. So if your users have multiple devices, like they have a work PC or they have a home PC or they have a tablet, which they use to log into terminal services, then you should have per user licenses so that each user can access via multiple devices. But let's say that you have a factory floor where there is a attendance system or a kiosk which is logging into the RDP terminal server, and all the users use this single machine to do their job or mark their attendance. Then a per device license makes more sense because you can give license to that one device and thousands of users can use that user to mark their attendance, and you'll still be paying for only one license. So that's what remote desktop services is. Component of remote desktop services is the remote desktop server on which the user logs in. And the second component is the remote desktop license server. This is where you install the licenses, which I just talked to you about. There are some additional components: remote desktop gateway, remote desktop connection broker, remote desktop web access. Once again, if the target of this studies is to become a junior level engineer, understanding of remote desktop is good enough. But otherwise, these are various components which are there in remote desktop, and this is a topic in itself, and we can go in a lot more detail if we need to understand all these things. For now, we'll move on to Citrix Server. Citrix is a company which was started by some ex-Microsoft employees, and its purpose was to provide solutions to the limitation of a typical Microsoft terminal server, Windows 2003H. Server 2008 onwards, with the evolution of Microsoft remote desktop services, a lot of those limitations are already handled. But still, because Citrix is focusing on a particular product, their terminal server product is usually perform better than Microsoft built-in terminal services, especially in terms of speed, access, and management. But most small businesses don't care for these to go for expensive Citrix, as their needs are usually catered by Windows Server remote desktop services. I would also like to inform you that though Citrix started as a terminal service product, but today there are many more products in market, and most of them are around to facilitate or make terminal services faster. But then there are others too. This is just about Citrix. It's an American multinational software company that provides servers and applications and desktop virtualization and networking, software as a service, and cloud computing technology. So, like I said, that they are doing a lot of products. So, some of the Citrix products are Citrix Workspace, Citrix Virtual Apps and Desktops, Citrix Content Collaborations, Citrix Endpoint Management, and Citrix Managed Desktops, Citrix Hypervisor, Citrix Cloud. So Citrix are doing a lot more products, and now when somebody says it's a Citrix server, we can't just assume that it is a terminal server for Citrix server. It could be something else as well. So Citrix has become a bigger and company with varied solutions. So you need to understand what is Citrix and what kind of solution is running on that server. So if somebody says it's a Citrix server, a wise question would be like, what exactly is it doing? So they can tell you, yeah, it's at virtual machines, or it is maybe an endpoint management solution or whatever. So now, depending on which product the Citrix is installed, it can be referred as Citrix Server or with any other suitable name. That's it, guys. So this module was about the various subsystems that we learned, and I hope you enjoyed it. I know these are a bit complicated things, but once again, the purpose of this training as of now is to give you a heads up on various technologies and try to get the the voodoo out of your mind of the various restrictions which are there in your head about various products, so that you understand these things and you can make an informed decision about them. And then when you are working on a specific product, of course you'll have to do a bit more research to dig deep into it. All right, that's it. I will see you in the next module now.